All right, hey everyone, welcome back to our next lesson. Today we're going to talk about increasing and decreasing functions. Very important topic for calculus. And for today is how do we describe the increasing and decreasing intervals of a function? Homework for today is in the OpenStax textbook, page 50, numbers 35 to 37 and 39. Just note that I want you to sketch the graphs. So it'll be similar to what we do in the classwork today. But in the instructions for the textbook, they don't say to sketch, but I want you to sketch the graphs. But you can also ignore the local extrema. So they actually say to identify the local extrema. I'm telling you that you don't have to do that. You could if you want to, but I'm not requiring it because we're not going to really go into detail about what that means today. I mean, just quickly, local extrema just means like local min and local max. So if you have, let's say you have the parabola, right? The local minimum would be 0, 0, right? It would be the vertex of the parabola, which would also be the absolute maximum, absolute minimum. But let me not get into too much detail. Yeah, so just make sure you sketch the graphs and you don't have to identify the local extrema. Okay. All right. Outside of that, let me get to the do now. So this one is another graph. All right, so here it is. The graph below gives a salesman's distance from his home as a function of time on a certain day. Determine the intervals of x on which the function is increasing and on which it is decreasing. Explain in words what this indicates about his travels on this day. It can be a story. Okay, I'm going to have you all share what your explanation was, but for now, I'm going to jump to the solution right over here. All right, here we are. So my response was the graph below gives a salesman distance, right? That was just a reiteration of the question, but I organized everything in a table. Okay, so I had increasing, decreasing, and neither. Okay, so from 8 to 9, it's his distance from home is increasing, right? And then also from 10 to noon, his distance is also increasing. And then the last interval that we have is 3 to 5. So that's like from here up to here. Okay. So those three intervals, his distance is increasing. Then we have the decreasing intervals, which is 1 to 3. So that'll be here to there, right? Decreasing. And then we also have 6 to 7. Okay, that part. Next we have 9 a.m. to 10 a.m. So that's here, right? That's neither. So this means that he's not moving, right? So his distance is neither increasing nor decreasing, which means he's staying still. So 9 to 10 a.m. And then we have noon to 1. And then last we have 5 to 6. Okay. And that covers all of the intervals here. Okay. So if you need to copy this part down, please pause the video here. If not, I'll be moving on to the next or the next example. Okay. All right. All right, so here let me just give you an overview of the rest of the lesson. So here we're going to talk about increasing, decreasing functions as indicated from the aim, right? And then next we're going to use a graphing calculator to find what's called the turning point and to answer a question, right? And then lastly, we'll end with the worksheet, okay? All right, with that being said though, let me jump to the first slide for this. Okay, here we are. So using the following vocabulary, right, less than greater than x1, x2, f of x1, and f of x2, and looking at the graph below, how would we define a function f as increasing over the interval x1, x2? Okay, so using the following vocab, how would you define a function as increasing over the interval x1, x2? Okay. Now, the answer I'm going to show you is not something you have to memorize per se, but it is something I want you to copy down. Reason being, it's notation that you're going to see a lot in calculus. So just to get familiar with that notation, please copy down in your notes. Okay. And let me just also jump to the next example because that's going to be our definition of decreasing functions. Okay, that's right over here. Okay, so using the same vocab, right, less than, greater than, x1, x2, f of x1, f of x2. Looking at the graph below, how would we define a function f as decreasing over the interval x1, x2? So yeah, instead of increasing, it's decreasing now, right? And yeah, we're going to use the same notation. Okay. All right. So let me show you the answer. Here we are. Okay. All right, we're over here. So this is the definition of an increasing function. Remember, please copy this. F is increasing on an interval I if f of x1 is less than f of x2. Okay, so the value of f of x1 is less than the value of f of x2 here whenever x1 is less than x2. Okay, so whenever you move from x1 to x2, right, it's increasing, right? Here we're indicating that x1 is less than x2, so x2 is to the right on the x-axis. It must also follow that f of x2, the corresponding value to x2, must be greater than the corresponding value to x1. So f of x2 is greater than f of x1. Okay, all right, pretty intuitive. You don't have to memorize it. It's just, yeah, just get familiar with this notation, right? F of x1, f of x2, x1, x2. All right, same thing for decreasing. Well, you know, a little different, but same notation. F is decreasing on an interval I if f of x1 is greater than f of x2 whenever x1 is less than x2. So note that x1 is still less than x2 here, right? So that matches up with the increasing definition. But in this case, since it's a decreasing function, f of x1, that y value has to be greater than f of x2. Okay, so as you can see on the graph here, f of x1 has a higher value than f of x2. Okay, whenever x1 is less than x2. So whenever you're moving from left to right, right, f of x1 has a greater value than f of x2. That means the function is decreasing. Okay, yeah, pretty intuitive. Yeah, let me move on to the next question. So as I said, we're going to use a graphing calculator. I'll go to the slide for this. And if you need to copy this definition, please pause the video here, or any of these two. Okay. All right. All right, first question. Using graph calculator to graph the function f of x equals x to the 2/3 using viewing window of -20 to 20 for x and -1 to 10 for y. What is the interval on which f is decreasing and what's the interval on which f is increasing? And then follow-up question to that is, let us define a turning point of a graph to be a point where the graph goes from increasing to decreasing or vice versa. What is the turning point for this function? Okay. By the way, if you remember the aim, or sorry, the homework, I mentioned like local extrema, right? Turning point in this case is another way to say local extrema, right? So local max, local min, right? That's where it goes from increasing to decreasing, right? The turning point where it wouldn't be either, right? So it would like be staying still. It's like the top of a hill or the bottom of a parabola, right? Okay, with that said, let me get to the actual solution. Okay. So yeah, I'm going to use so I have the answers here, but let me show you on the graphing calculator. So let me share my screen here for the calculator. Okay. All right, so I'm going to use this TI-84 emulator for this. And then if you don't have a TI-84, by the way, you should email me. So the math department is handing out graphing calculators. So just email me. If you don't want one, you can also use Desmos, which I'll be showing you examples of later on. But for this question, we'll be using the graphing calculator. Okay, so the function was x to the 2/3, and I actually show it here, but let me show you how I actually inputted the information. So x to the 2/3, right? So x, and then caret, and then I'm going to write parentheses 2 divided by 3. And then the window that was given in the question was -20 to 20, and then -1 to 10. Okay, so -20 to 20 for x, min x max, scaling is 1, -1 to 10 for y, scaling is also 1 for that. The scaling wasn't indicated in the question, but yeah, 1 is fine here since the range is small, right? With that said, though, let me show you the graph again. Okay, so as you can see, right, it's kind of looks like a sprinkler. But yeah, it's decreasing from negative infinity to 0, and then increasing from 0 to infinity. So decreasing from negative infinity to 0, and then 0 to infinity, it's increasing. All right, let me get back to the lesson. Okay, so how you would write that answer is negative infinity to 0. Note that here the negative infinity and infinity are in parentheses, right? And then the 0 is in brackets. Now, you could debate about this, like you could debate about whether or not to include the actual turning point, right? 0 here. So the origin 0, 0 is the turning point. But for the sake of this class, we're going to include the turning point. And yeah, as you can see in the group work answers here, so just a heads up, right? Everything's in brackets, right? Besides the infinities, which we won't see just yet in the first few questions. But yeah, so negative infinity, that'll be in parentheses, but the turning point, you could have it be in brackets. And note that the 0, 0 is in both the decreasing and increasing intervals. So that's the norm we're going to go with in this class. Yeah, that's on the syllabus, by the way, that that the pre-calc teachers decided on. Okay. Yeah. Next question though was about the turning point, which I just mentioned actually. The turning point for this function was 0, 0, right? So just where it goes from increasing to decreasing, right? Where it changes, right? So in this case, it's 0, 0. All right. With that being said, let me get to the classwork. So yeah, just a few practice questions on increasing and decreasing intervals, which will mimic, the questions that you'll see on the homework tonight. All right, so part 1. For the following 4 graphs of functions, determine the intervals on which the function is increasing and those on which it is decreasing. The first one is decreasing on 1 to 2, right? So from here to here, it's decreasing. And then there are 2 increasing intervals, so -1 to 1, right? That's here to here. And then it's 2 to 4 from here to here. Okay. In these 4 questions, by the way, everything's on a scale of, everything's going by ones. Okay, so you just read everything on that scale. Okay. All right, so that's your answer for the first one. Question 2, we're going to use this graph, right? And then decreasing from -2 to 0, so here to here. And then it's increasing from 0 to 1, so from here to here. And then decreasing again from 1 to 3. Okay. If you need to copy any of these, please pause the video here. Otherwise, I'll move on. All right, next we have questions 3 and 4. Okay, and I guess you can still see this, which is fine. That's good. All right, and then all right, let me just move on to question 3. So first thing is -3 to -2. It's decreasing, so that's this part, right? -3 to -2, and then the next part is -2 to -1. That's increasing, which I wrote here, right? Increasing here. Next part is -1 to 1, which it's decreasing. And then it's followed by increasing, so that's 1 to 2. That's the second portion that's increasing. And lastly, you have 2 to 3, which is decreasing as well. All right, last question, number 4. At least for this part, we're going to have decreasing from -2 to -1, so that's this part here. And note here that it's not this graph isn't actually a function, or this relation isn't a function, because you have 2 y values for the same x value. Yeah, but doesn't really matter, I guess, for the sake of our question. We just have to identify the increasing and decreasing parts. But yes, this is not a function. Okay. -2 to -1, by the way, and then -1 to 1 for increasing, and then last we have 1 to 2 for decreasing. Okay, and you'll see that answer right here. All right, if you need to copy the answers to 3 or 4 down, please pause the video here. Okay. All right, the other questions have to do with the graphs. So I want you to make your own graph, right? And this is much like what you'll see on the homework tonight. So please remember to draw the graphs on your homework. Okay. All right, first question, f of x equals x to the 2/5. And here I use Desmos, okay? And I'll show you the first one actually. So x to the 2/5. So here we are. Okay, so here I have Desmos, online graph calculator that you can use. X to the 2/5. This is what it looks like, right? And yeah, as you can see, it's pretty much the same thing as our example earlier, right? Negative infinity to 0, it's decreasing, and then 0 to infinity, it's increasing. Okay. But yes, you can see the answer right here, right? Negative infinity to 0. And yeah, just remember to include your turning points in the interval. So brackets around the 0, right? And then increasing 0 to infinity. All right, it's followed up by question 2, x squared minus 5x, just parabola, right? And by the way, you can identify the local max, local min. In this case, it's a local minimum, right? Because it's a low value. That'll be essential to answering these questions. Okay, actually, let me show you this on Desmos as well. So, but yeah, here is the answer: negative infinity to 2.5, it's decreasing, and then 2.5 to infinity, it's increasing. So x squared minus 5x is our function here. Show you. Yeah, this is what it looks like. And then on Desmos, it actually identifies the local min for you. You just click that point, right? So 2.5 comma negative 6.25. In this case, though, you only have to, since we're identifying the increasing, decreasing intervals, you only have to worry about the x value, okay, not the y coordinate, okay? So yeah, it'll be from negative infinity to 2.5 and 2.5 to infinity. Okay, again, that's your answer right here. All right, next two questions, and then I believe we're done. Okay, question 3, 2x cubed minus 3x squared minus 12x. This is going to be decreasing from negative 1 to 2, which I show on the graph here, negative 1 to 2, and then increasing from negative infinity to negative 1, and then increasing from 2 to infinity. Okay, so increasing on these intervals, the left portion and the right portion, and then decreasing from negative 1 to 2. Okay, yeah, that's your answer right there. I'm actually going to show you, I'll show you how to identify the local max, local min on your TID4 if you have one, or other graphing calculator. I'll show you that for the next example though. But if you need this solution here, please pause the video here. Okay, question 4. So that's x cubed plus 2x squared minus x minus 2. And as you can see, right, this is not easily identifiable from the graph, right? You would have to, well, with Desmos, they do it for you, but if you just have the graph, right, it's in decimal, so you have to identify that. So let me show you the graph calculator way to do that. Okay. I don't know why this is not turning on. I'm gonna restart it. Okay, sorry about that. All right, I'm gonna just restart my calculator. All right, should be good to go now. Here we are. All right, so you had x cubed plus 2x squared, and then minus x, and then lastly minus 2. Okay, I'm gonna adjust the window if need be, but yeah, let me just graph it for now. All right, so I'm gonna change the Y window, right, the vertical window. Can't see that. Okay, so I'm gonna change that to let's try negative 20 to 20. I'll change the scaling to 2. Graph it there. All right, so better view. Okay, so what I wanted to show you was how to find the local max, local min. So you can press second trace, right? So second that button right there, and then trace. And then you have this option of min and max. I'll identify the local max first. So option number 4. And you're going to be prompted left bound, right bound. So left bound just means you have to go left of the local max. You press enter. And then right bound, you have to go right of the local max. Press enter. And then last prompt is guess. So just guess where it is. And then it'll show you the local max is negative 1.54, which I round to negative 1.55. And then the y value is 0.63, which we don't have to copy down, but yeah, there you have that coordinate, right? So negative 1.55 is that x coordinate there. And then for the local min, I'm going to go back to second trace, option number 3. So left bound, right bound, and then guess. And you're going to see it's about 0.22. And y coordinate is negative 2.11. But yeah, we only need the x coordinate, so I'll round it to 0.22. Yeah, with that being said, let me get back to the solution. Okay, so yeah, decreasing from negative 1.55 to 0.22, right? That's this point here to here, right? From the local max to the local min, right? That's the x coordinate. Those are the x coordinates, or the interval on which it's decreasing. And then it's increasing from negative infinity to negative 1.55, right? That's this part here. And then we have increasing also from 0.22, that's this point here, to infinity. Okay, and again, everything's in brackets, right, besides the infinities. Okay, but yeah, that's the solution here. If you need this part, yeah, please pause the video here and copy it down. But I believe that's all I want to say for today. Just remember to, complete your homework. As a reminder, it's page 50, numbers 35 to 37, 39, also in the OpenStax textbook. Please sketch the graphs. If you don't, I will have to penalize your grade. And you don't have to identify the local extrema. Just as a recap though, right, the local extrema was actually those points that we just identified, right? So negative 1.55, and then whatever the y coordinate was, and then 0.22, and whatever the y coordinate for that was. Okay, that's what I mean by local extrema. You don't have to identify that, but yeah, feel free to. But yeah, that being said, I hope you have a good rest of the day, and I'll see you all tomorrow in class.